Okay, we've been looking at indices, and it's time to move into the negative side of the index world. And so, a couple of questions on screen here. What does a negative power mean? We're pretty familiar with what positive powers mean. I mean, it's quite intuitive. It's just an easier way of writing out all this guff. 2 to the power of 2 to the power 2 times 2 times. I just want to multiply a number, and we often want to do that in maths. We want to take a number and just multiply it over and over and over and over again, because we do lots of iterative stuff. Iterative meaning just repeat stuff. Well, we might want to do this 50 times. I don't want to have to write all this out. So if I want to show that calculation, indices are great. They save us a lot of time, and it makes sense. 2 to the power. We know, we get it. We've been using squares and cubes for ages. But what's this negative? What is 2 to the minus 4? What does that mean? What does that equal? What's its value? Right, so we've got to think about this, haven't we? So there's a couple of ways of doing it. I wouldn't mind actually just exploring this for a moment. 2 to the minus 4. So if we go, okay, what's 2? Can we start with 2 cubed? 2 times 2 times 2. We know that's 8. And then we can go to 2 squared. We know that's 4. And 2 to the power of 1. We know that's 2. But we also, what we're doing here is we're from 8 to 4 to 2. We're halving, aren't we? We're dividing by 2. We know all this stuff, but in a moment we're not going to know it, because now my powers are dropping by 1, and so my next power has to be minus 1, doesn't it? But the pattern is, if I drop my power of 2 by 1, then I am, what I'm doing here is I'm dividing by 2, aren't I, each time? I'm dividing by 2. Dividing by 2. So if I keep dividing by 2, 1 divided by 2 is a half, or 0.5. I'm going to write that as a half. So there, I've found, that's got to be right, isn't it? Just using the logic of that, pattern, 2 to the minus 1 must be equal to a half. And 2 to the minus 2, if I continue dividing by 2, which I have to do, half divided by 2, what's a half of a half? That's a quarter. Okay, well, this is interesting. So 2 to the minus 2 is a quarter, and I could keep going, and I could actually find out what 2 to the minus 4 is by just halving and halving again. And what we might find is halving is just, look at this. So look at the denominator now. Look at the denominator and the power. The denominator and the power. The denominator and the power. Can you see what's going on there? So this represents the power of 2. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. So what we end up with is actually 1 over 16 is 1 over 2 to the 4, isn't it? 1 over 8 is 1 over 2 cubed. So would it be fair enough to say that 2 to the minus 5 will equal 1 over 2 to the 5, which is 1 over 32? It would be fair to say. So the first thing we notice here is that we can deal with negative powers by making them positive in the denominator of a fraction under 1. Right? So 2 to the minus 5 is 1 over 2 to the 5. So that's the first thing to sort of discuss. And we'll come to this algebra in a moment. Another way of looking at this, so if I've got, let's just take, I'm going to take x to the power of 0 divided by x to the power of, what shall I say? I'll say 6. X to the power of 0 divided by x to the power of 6. Now, same base. What are we going to do with the powers? We're going to subtract them, aren't we? So x to the 0 minus 6. Would that be correct? X equals x to the minus 6. Okay. But would it also be correct? X to the 0, that's equal to 1, isn't it? 1 divided by x to the 6. So I could say that is 1 over x to the 6. So these two must be equal. That, I'm not sure, is very, very helpful. So these two must be equal. These two terms here, x to the minus 6 and 1 over x to the 6. And does that match up what we did here? Yes, it does. I've dealt with a negative power by making it positive underneath 1 in a fraction. So what does x to the minus 6 equal? It's equal to 1 over x to the 6. What does 2 to the minus 4 equal? Well, it's equal to 1 over 2 to the 4, which is 1 over 16. So that's how we deal with negative powers. Righto, so let's do some examples. Express each of these using positive indices. So I'm just pinching these out of the book again. Express using positive indices. Okay, so b to the minus 4 is the first one. B to the minus 4, what's it equal to? We're going to make it positive underneath 1. So b to the minus 4 is 1 over b to the 4. Excellent. B, 3x to the minus 4 y squared. Okay, how do we deal with that? Now this is we've got to write it as a positive index, right? So I need to deal with this. Well, I can deal with it by putting it underneath in a fraction, but this time the numerator is 3y squared. So what happens here is the 3 and the y squared stay on top because they're positive powers. The x to the minus 4 becomes x to the power of 4 underneath in the fraction. Okay, so let's have a look at another one. C, 5 over x to the power of minus 3. So now I've got negative 3 underneath in the fraction. It works the other way too. I can bring that into the, I can flip it into the numerator and it becomes positive 5x cubed. Okay, so the negative, so you can think of negative powers as becoming positive powers in the other part of the fraction, whether that be the numerator or the denominator. Okay, let's have a look at one more example. D, 3a squared over a to the power of 5, and this is all cubed. Okay, so how are we going to look at this one? Well, do we do the power of 3 first, or do we do the simplify inside first? Maybe we simplify inside first. This is going to become 3a. Now this is division, isn't it? 2 minus 5, so it's 3a to the minus 3 in here. 3a to the minus 3, think about that, 2 minus 5. And that is all raised to the power of 3. How do we deal with that? 3 cubed, 27. Power over power. Minus 3 times 3 is minus 9. Write it as a as a positive power. Put it in the denominator. It becomes positive 27 over a to the power of 9. Okay. That's probably enough for this screencast. There are some tougher questions later on in the exercise. We're talking about 3G, but you can certainly get started on it, and we can discuss in class some of the tougher ones. So let's leave it at that for now. See you later.